Welcome back to the YouTube channel. Today I'm going to go over everything exponential. I hope it covers enough for you. So let me know in the comments if I didn't cover something and you want it covered. So what is an exponent? What is an exponential? So 4 to the x means 4 times itself, 4 times 4, x times. So 4 squared equals 4 times 4. 4 to the 4 to the 2 equals 4 times itself twice. 4 to the third equals 4 times 4 times 4. 4 times itself 3 times. 4 to the fourth equals 4 times 4 times 4 times 4. So if we were solving and it said 9 to the x equals 81, 9 to what power equals 81? Well, just think this is probably a whole number because it's an exponential. So it goes 9. Then 9 times 9 is 81. Oh, well, 9 times itself twice is 81. So 9 times 9 equals 81. So x equals 2. Another thing to note is that any base to the 0th power equals 1. Then, also, if we have a root exponent, so let's say 4 to the 1/2 power, this 2 on the bottom is really the base of a root function. So this would be the second root, which is really just the square root of 4, which that means what number times itself is equal to 4. So this is also exponential because, yes, this is also a little bit of exponential. So what number times itself is 4, and that would be 2. 2 times itself. This is 2 times itself 2 times. So it has to be a number times itself this many times equals the number under the root. So what the main point of this was, the bottom number, this denominator, is the base of the root. This base is what is under the root, and this numerator would be, if this numerator was like 3, it would be 2, the root of 4 cubed. Or it'd be the root of 4 cubed. But we just do root of 4 quantity cubed. So let's move on. That's just what an exponent is. What's fractional exponents? Let's go. So the exponential function, the standard form is y equals a times b to the power x minus h plus k. So what does that mean? A is your stretch or compression. Your b is just your base. Our base over there was a 4. Here is our h. Our h is our horizontal shift. Then k is our vertical shift. So let's see the graph of y equals 2 to the x. Well, I graphed a couple points for you here. At 0, again, I said any number to the 0th power is 1. So, well, not equal 0. Don't put 0 to the 0th power. But 2 to the 0th power equals 1. Then 2 to the first power, 2 times itself 1 time, is just 2, is 2. Then 2 squared is 4. But 2 to the negative first power, so 2 to the negative first power equals 1/2. So what you do when it's a negative is you just flip. You flip the exponent. You flip the equation. So if it's 2 to the negative third, it equals 1 over 2 to the third, and then that would be 1 to the 8th. So over here, if I had x equal negative 3, it would be 1/8. Would be the point. Now let's investigate the function of y equals 2 to the x. Here's our graph again. Then our xy is negative 3, 1/8, negative 2, 1/4, negative 1, 1/2, 0, 1, 1, 2, 2, 4, 3, 8. So 2 to the negative third is 1/8, 2 to the negative 2 is 1/4, 2 to the negative 1 is 1/2, then like 2 to the third is 8, 2 to the fourth is 16. Didn't put that on there. But domain, all real numbers. You can put any number. into this x, and you will get something back. Even if it's negative, again, you just flip the equation, and then it's just 1 over. If you do negative 1,000, well, 2 to the negative 1,000 is equal to 1 over 2 to the 1,000. So it's still a number. It's just very close to 0. And that's what I'm here to say. The range is y is greater than 0. There's an asymptote at y equals 0. Because again, if you have 0 equals 2 to the x, what number for x could you put in to get a y of 0? Because 2 to the 0 is 1. But you're like, oh, so 2 to the negative infinity is 0. Well, infinity is not really a number. It's like more of a concept. But 2 to the infinity is still a number that is not infinity. Don't know why I'm ranting about this. But you cannot get 2 to any number to equal 0 because 2 to the 0th, 2 to the lowest number, well, 0 would be the lowest number you would think, is 1. So 2 to the negative 1,000th, again, is just 1 over 2 to the 1,000th. And 1 over 2 to the 1,000th power is definitely not 0. It is very close, though. So asymptote reaches for infinity in the x values and slowly goes down in the y values, then reaches for infinity in the y values, and it just keeps going. Our asymptote is y equals 0. It is continuous. The y-intercept is 0, 1. There are no x-intercepts, again, unless you shift the graph by moving the k value. Then there is no symmetry. So let's keep speeding. Now we have the rules of exponents with some examples. The rules of exponents. A to the m times a to the n equals a to the m plus n. So 2 squared times 2 to the 4th is 2 to the 2 plus 4 equals 2 to the 6th equals 64. If we look at this, 2 squared, 4, 2 to the 4th, 16. So then 4 times 16 equals 64. So it checks out. A to the m divided by a to the n equals a to the m minus n. Very similar to this first one. So 2 to the 5th over 2 to the 3rd equals 2 to the 5 minus 3 equals 2 squared equals 4. So we can check that again. 2 to the 5th, 2, 4, 8, 16, 32. 32 divided by 8. 32 divided by 8 is 4. Boom, checks out again. A to the negative n equals 1 over a to the n. Well, we were just talking about that. When it's a negative exponent, you are just going to flip it and then do your normal things. So 5 to the negative 2 is equal to 1 over 5 halves. 1 over 5 squared is equal to 1 over 25. A to the 0th power equals 1, where a is not equal to 0. Again, any base to the 0th power is equal to 1 if the base is not 0. Then the absolute value of a squared is equal to the absolute value of a, quantity squared, is equal to a squared. Because this absolute value will make it positive, but this squared it'll make it positive anyway, because like a negative 3 times a negative 3 is a 9. But this number, this exponent, could be 2, 4, 6, 8, 10. Don't really matter what it is, but it has to be even, because if it's odd, if it's to the 3rd, negative 3 to the 3rd is negative 3, 9, negative 27. That's negative, and an absolute value here would not give you a negative. So let's keep moving. Some more rules of exponents. Just a couple more. So AB all to the m is equal to a to the m times b to the m. Yeah, so you just distribute this m into it. So also you could say the inverse. Well, a to the m times b to the m is equal to a, b to the m. You could take the m out of them. Doesn't matter, it goes both ways. So 3x to the 4th is equal to 3 to the 4th, x to the 4th is equal to 81 x to the 4th. Then a over b to the m power, a over b quantity to the m power is equal to a to the m power divided by b to the m power. Again, you just distribute this m into the a and the b. So if we did x divided by 2 to the third, it would be x to the third over 2 to the third, and it would be x to the third over 8. Got it. Now, a to the m quantity to the n is equal to a to the m n. So these exponents, when it's one exponent to another exponent, the exponents are multiplied by each other. So 2 to the third squared is equal to 2 to the sixth equals 64. We can check this one. This is 8. 8 squared is 64. Wow, it's crazy. Thank you so much for watching. I hope this helped or was a great review. And I hope to see you next time. I appreciate you. Thank you.